Hello my dear students, once again welcome back to your online class. So today's video will be beginning a new chapter, that is the differential equation. So in your junior classes you have already learned what is this equation. So like we have studied about the linear equations in class 9 and 10. So basically in equation we have a left hand side and a right hand side, okay, which is related by a symbol equal to. The right hand side is equal to the left hand side. So similarly in the differential equation also we have a left hand side and a right hand side, but in this differential equation we have the derivatives. Okay, so we have a dependent variable, the independent variable and the derivatives. Okay, maybe the first order or even of the higher order as well. So any expression that involves the dependent variable, the independent variable and the derivative is known as a differential equation. So here I have written three examples of the differential equation. So here 1, 2 and 3. So here you can see that we have a differential or the derivative of the first order, where x is the independent variable and y is the dependent variable. In the second example we see that here I have a second order derivative and there I have only the independent variable. And in the third I have written the second order derivative, but the second order derivative has got some power. Okay, so all these kind of expressions which involves the dependent, independent and the derivatives are said to be the differential equation. Now coming to the order and the degree of a differential equation, so you will be asked to write down the order and the degree of the differential equation. So what is it? So very simple, the order of the differential equation is the highest derivative involved in that expression. So like in this, the first one, what is the highest order derivative? It is the first order derivative. So the order is equals to 1. In this we have the second order derivative. So the order will be equals to 2. And here also I have the highest order derivative. Here is the second order. So the order here is also equals to 2. So now coming to the second term, the degree of the differential equation. So what is the degree of the differential equation? The degree of the differential equation is the power of the highest order derivative involved in that expression. Like in the first case here, the highest order derivative itself is the first order, and here what is the power of it? The power of it is equals to, again here I have it is equals to 1. So here the degree is also equals to 1. So in this, though the order is second, but what is the power of the second order? It's still 1. So the degree is also equals to 1. But if you see in the third example, you see that the power of the highest order derivative, that is the second order derivative, is equals to 2. So here the degree will be equals to 2. Suppose even if here in the first order derivative I have to the power 3. So still the degree will be 2, because the degree means it is the power of the highest order derivative involved in the given expression. So in this differential equation, basically we will be doing two things. The first is the formation of the differential equation, and the second one is getting the solution of a differential equation. So to find the differential, to form the differential equation, so what we must do, we have to go on differentiating the given equations until we eliminate the constant. Okay, and in the second one, to get the solution of the differential equation, we just integrate. Okay, we integrate until we find the solution, and on either of the side we add one constant. So that is how we form the differential equation and also get its solution. So we'll try to form the differential equation and also find its solution. So here I have taken two questions from your textbook. The first one, you have to find the differential equation of the curves, of the family of the curves given by the expression y is equals to m of x. So this is very simple. So how do you do? So just as we have learned earlier, so we simply differentiate it with respect to x. So differentiating both sides with respect to x. Okay, so what we get? So I get dy by dx will be equals to d by dx of m of x. So this implies that dy by dx will be equals to, now m is a constant, the question also says m is a arbitrarily constant, so it comes out of the differentiation sign, and then d by dx of x is equals to into 1. Okay, so no need to write. So what do I do? So let this be equation 1. So I substitute the value of m in the given equation and then I obtain the differential equation. So therefore now substituting m in equation 1. So what do I get? I'll simply get y will be equals to, what does the m means? M means it is dy by dx into x. Okay, so which is the required differential equation. So this is how we find or we form the differential equation. It's very simple. So again, number 5, if you see what do, we follow the same procedure. Okay, I find the value of a and then substitute in the main equation. So let this be equation 1. So now differentiating both sides with respect to x, what do I get? I'll get. So now since this is not x, so we follow on the chain rule. Okay, so the derivative of y square will be equals to 2y dy by dx plus 2a dy by dx. Why 2a outside? Because 2 and a are constant, so they come out of the derivative sign. So plus derivative of x square is 2x is equals to derivative of constant is equals to 0. Okay, so sorry, here it's minus. So dividing throughout by 2, what do I get? I get y dy by dx minus a dy by dx plus x is equals to 0. So from this I'll get the value of a. So what do? I'll take this one here. So a dy by dx will be equal to, now suppose if I take this one there, the rest remain in its own place. So it will be y dy by dx plus x, or this implies that a will be equals to y dy by dx plus x divided by dy by dx. So now what will I do? I'll substitute the value of a in equation 1. So on substituting, what I get? I'll simply get it will be equals to y square minus 2. Now a here it means y dy by dx plus x divided by dy by dx. Okay, so plus x square equal to a square. Again here it will be y dy by dx plus x divided by dy by dx whole square. So this is how we obtain. Now if you simplify it, okay, so the expression that you obtain is the differential equation of a given equation. So this is how we form the differential equation according to what the question asks us to find. So now we'll try to solve 2 more questions related to the solutions of the differential equation. So here again I have taken 2 questions from your textbook to find the solution of a differential equation. So as I stated earlier as well, to find the solution, what we need to do? We simply need to integrate the given differential equation. So we'll try to do these 2. Okay, so what do you do? So the given differential equation, arrange it in the form like this, like dy equals to x cube plus x square minus 2 by x into, so this goes there, so it becomes dx. So once you get in this form, so what do? We integrate both the sides. So so integrating both sides. Okay, so it will be integration of dy equal to integration of x cube plus x square minus 2 by x dx. So simply the integration of dy will be equals to y equals to, now the integration of x cube, it is x to the power 4 divided by 4 plus integration of x square is x square, it will be x cube divided by 3 minus 2. Now the integration of 1 by x, it is log of x plus c, where c is the constant of integration, and hence this itself is the required solution of a differential equation. So this is also known as the general solution to the differential equation. So similarly we can solve number 2 as well. So again we will arrange this in the form of dy equals to sine of x minus x into d of x. So once we reach this step, we integrate both the sides. So integrating, we get dy equals to integration of sine of x minus x into integration of dx. So this implies that integration of y is equals to y equal to the integration of sine x is equals to minus cos of x minus integration of x is, it is x square divided by 2 plus c. So which is the required differential equation. So there are many solved example in a given book, or nowadays, as you know, you can also take the help of a Google, and then you can try to solve as much as questions related to the formation and also getting the solution of the differential equation. And as I have been saying in each of my videos, that it is very important for you to learn the formulas of trigonometry, the differentiation, and as well as integration. Without it, be sure that you will not be able to do even a single question of this calculus. So dear students, please learn these formulas. Thank you.